Okay, so this is pages 317 and 318 from the Springboard book. I'm going to go over every single one of these problems at least one way. Some of them I might go over more than one way. But on number 1, it says, which side of triangle ABC is the opposite angle A? So on here, we have A. The opposite side would be what? Oh, yeah. Sorry. I was expecting you to say BC. And yes.
My mom can't pick me up. Yeah.
So, shh, guys. Brandon. All right. So again, A, opposite of that is CB. So that's our answer. Then on number 2, in this triangle, PQR, identify the hypotenuse, the adjacent leg, and the opposite leg for R. So again, we're basing it all off of angle R. So the hypotenuse is the one across from the right angle. So this is our hypotenuse. PR is the hypotenuse. Then you have the one that's next to R is QR. So this is adjacent, right? Again, that's our adjacent leg. And then PQ, that's the one that's across from R, so that would be the opposite leg. I don't know, just because. Now, on number 3, there are multiple answers for 3. There's not one correct answer, one wrong answer here. Now, you did have to find, before you did anything else, the other 2 parts of this original triangle. So, on this original triangle, we had 5, we had 12. The other missing side is what? 5, 12, 13. This is one of our triples, right? It's a 5, 12, 13. You don't actually have to use anything else to find this. You don't have to use sine. You don't have to use cosine or tangent. You don't even have to use Pythagorean theorem. It's a Pythagorean triple. You should be able to look at that one. We have a right triangle, 5, 12, 13. There's no work to do. Now, the other angle that's missing, we also are supposed to find that. So we have the 90-degree angle. We have the 22.6. We need to find the missing one. You can say that all 3 of these have to add up to 180 and subtract both of these from 180, and you're left with that angle. Or, again, the 2 acute angles have to add up to 90. So you could say 90 minus 22.6, and that would also give you that angle. So what is 90 minus 22.6? 67.4. So now, once you have those pieces, part B asks you to draw and label a triangle similar to this given triangle. Include each side, length, and angle measure. There are lots of different ways that you could do this. So I'm going to use a sticky note this time because I don't have a lot of room on this paper. So we got B. If I drew a triangle that looked pretty much exactly like that, except I labeled it so that all the sides were double in length, 10, 26, and 24. Yeah, I didn't go in order there. So I doubled each one of those sides. What about the angles? Do those change? No. Angles stay the same in similar triangles. So that's 22.6. This one's 67.4. And again, that would work. So now C. C, again, there's lots of different answers because C is based upon your 2 triangles that you have. So with the one that I drew, it says state the scale factor of the triangle given in part A to the triangle you drew in part B. So, again, it says I'm going from the original to the other one. The new one is the one that goes on top when you do a scale factor, right? So for part C, this one would go on top. Now, I already know what the scale factor is without doing any work because what did I multiply every single side by? 2. So I don't have to do any work here. I know my scale factor is 2. Now, if you really wanted to show the work for the scale factor, you could say 24 over 12, or 10 over 5, or 26 over 13. But really, whatever I multiply that original triangle by, that's my scale factor. All right. Now, on number 4. So let me move that off to the side. Lisa wants to make a larger bandana similar to the bandana shown. So they said the shorter leg of the larger bandana is 15 inches. How long is the hypotenuse? Now, there is more than one correct way to do this. You can use similar triangles, or you can use the trig. All right? Because, again, our trig ratios work because any triangle with the same angle measures must be similar. So, I'm going to show you guys 2 different methods that you could do for this problem. The first method, you're going to have to find the hypotenuse no matter what. So, let's go ahead and find the hypotenuse of this piece. And we can do our these 2 sides as A and B, and our hypotenuse would be our C value. So using Pythagorean theorem, I'm going to find the missing side, because we would have to have that first no matter what. So on here, 10, I'm going to plug in for the A value. I'm going to plug 8 in for my B value, and then we're looking for my C value, which is going to be the hypotenuse. So C squared equals 100 plus 64. C squared equals the square root of 164. Now, for this problem, I could leave my hypotenuse like that. I don't have to change it to a decimal. So square root of 164, I'm going to leave that for the hypotenuse. And then I need to find the hypotenuse of the bigger triangle. All right, so if I drew the bigger triangle here, they said that this side is going to be 15, right? I'm looking for the hypotenuse. So if I set this up using similar triangles, I can do 8 over 15 equals the square root of 164 over x. Cross multiply and solve. 8 times x is 8x. This is going to be 15 radical 164. And then divide off the 8. And again, I haven't rounded anything yet, because if you round something early on, you're going to get a little bit of rounding error, right? I want to try to have the least amount of rounding error possible. So on here, I left everything as an exact value. Now, I didn't simplify anything, because it didn't say how I wanted my final answer. So it doesn't really matter if you leave it as an exact value or if you leave it as a decimal. But I'm just going to change mine to a decimal, so I didn't simplify anything yet. I'm just going to plug that whole thing into the calculator. So I'm going to do the square root of 164, and then multiply that by 15, and divide by 8. So we have 164. So square root, oops, where's my square root on here? Yeah, there it is. Square root of 164 gives me that, times 15, divided by 8 is 24. And it didn't say what to round to, but it's 24.01. I'm just going to round this off to a whole number of 24. All right. So x is 24 inches. And that's the answer that I'm looking for. I was looking for the bigger length of that, or the hypotenuse for that new right triangle. Now, the other way that you could have done this, you could have used trig. If you wanted to use trig, what you would have had to have found is one of the missing angles. So you could have found one of these missing angles, and then use that in your new triangle in order to find the hypotenuse. So I said I was going to do this another way, all right? Because there's more than one way to do these problems. So if I wanted to do the other way, I don't even have to find the hypotenuse if I don't want to, because I can just use these 2 pieces. Let's say I'm going to find what angle B is. So for angle B, we have, this would be my opposite and my adjacent piece. Opposite and adjacent is tangent. So I could say tangent of B equals 10 over 8. Well then, in order to find the measure of angle B, I do the inverse tangent of angle B. So, inverse tangent inverse tangent of 10 over 8 is 51.34. I'm going to round it off there. 51.34. Now, normally I tell you guys to round it off to a whole number if it's an angle measure. Why didn't I round it yet? It's not what? Well, this is my angle measure for angle B, but what are we actually finding in this problem? The hypotenuse. So this isn't the final answer I want, right? So I'm not going to round it off to a whole number because I want extra decimals so that when I go to find my value, I'm not going to have a lot of rounding error. So now, I'm also going to wait to delete this from my calculator because maybe I can just get away with using what's already in my calculator later on. So now to find the hypotenuse of the new triangle. All right, I'm using the same angle, but now I'd be using this part would now be my 15, right? So I have the adjacent, and I want to find the hypotenuse. Adjacent and hypotenuse is which one of my trig ratios? Cosine. So I could say cosine of the angle I just found, 51.34, is equal to the adjacent, which is now 15, over the unknown piece, which I'm trying to find. So now we're going to have to solve this. So I have the x, move it over to the other side. So x times cosine. Now, Miss Oswalt teaches us a little different. She treats each one as a ratio, which is fine. But you do the same exact operations as what I'm doing here, and you end up with the exact same answers. I just show it as one step at a time. All right, so I'm solving it like an equation. I brought the x over, and now I'm going to get rid of my cosine here by dividing it off. So I have 15 over cosine of 51.34. So now, I still have this number in my calculator. I haven't got rid of it yet, so I'm going to do cosine of that value that's in my calculator. So cosine of, on this calculator I'm going to say answer, is that. And then 15 divided by that number, so 15 divided by my answer, is 9.37. Wait. Oh. Sorry. I had a mistake. I forgot my division key. When I typed in that last answer, I multiplied. So it should give you the right answer. I typed it in wrong. Hold on. Let me retype it because I hit the wrong button. So divide by cosine of. I did all that work to keep my answer exact, and then I messed it up. But you see it is 24.01. So again, if we round it off to 24, we're good.
So when are you doing a rounding in? When do you round it in and when do you not round it in?
Well, this one, again, it doesn't say exact value. It doesn't say round off to anything. So on this one, I don't care if it was an exact value or if it was rounded on this one. I'd give you rounding directions on a test.
What's the problem with just finding the scale factor and then putting that on the calculator?
Well, that's essentially what we did on the first method here, right? Because on here, this is the scale factor.
Yeah.
So it's the same work because then it's just ran out as the scale factor times instead of doing it as a proportion. But it's the same work as this one. Again, there's multiple ways to do each of these problems. So I showed you 2 methods. There's more than 2 methods. All right. Okay. For number 5, use your calculator to evaluate the following rounded to 3 decimals. These are just straight up plug it into the calculator. So plug and chug here. We got cosine of 54. Cosine of 54 is 8 point. Sorry, I read the wrong decimal there. 0.5877. So we're going to round that up. I'm going to go to 3 decimal places. Again, I recommend you guys go to 3 decimal places. Usually, this one's actually telling you to go 3 decimal places. So 0.58, and that next 7 gets rounded up to 8 then. So it's 0.588. Sine of 12 is 0.208 if you round that up. 0.208. Tangent of 67. Tangent of 67 is 2.356. 2.356. Now, if you did not get those answers on number 6, most common mistake is having your calculator in the wrong mode. Anytime you are doing anything with trig, you want to make sure to check your mode. All of what we do in geometry is in degrees. Your calculator for this class should always be in degree mode. When you get into higher level maths, even towards the end of Algebra 2, trig, pre-calc, calc, that's where you start using radians. Again, we don't touch radians in this class, so it'll always be degree mode for your calculator. All right. Now, on 6, find each of the following ratios. Write each ratio in simplest form. So, for this one, and all we're doing is using the triangle in order to write the ratios. There's a missing side. Does anybody know what the missing side there is? What is it? 24. How do you know that?
Pythagorean theorem.
All right, you can do Pythagorean theorem. Do you have to do Pythagorean theorem?
No, you can do the whole.
I never learned the Pythagorean triples.
725. Yo.
That's one of our triples.
I was never taught that.
So, again, that's one of our triples. I'm not going to zoom it out. If you want to come take a picture of this, that's fine. I'm not going to zoom it out because this, like, recording might get messed up. So if you want to come take a picture of the paper instead, you can come up here and take a picture of the paper.
Shut up, Tyler.
He's taking it from across the room. So like, better picture than people
I'm gonna go. I need to get a better picture.
No, that's fine. Again, when we talk about the Pythagorean triples, so the ones that are on this paper that I just showed, this one is only showing the root Pythagorean triples. It's not showing the entire family. So like on this first one, I show the next one in the family of the 3, 4, 5 because all of these have other triples if you multiply by a scale factor. So if I multiply this by a scale factor of 2, I get 6, 8, 10. If I multiply by 3, I'd have 9, 12, 15, and so on. So I would say, again, the two most important are these two that I have starred. I highly recommend really the first 4 because they save you a lot of time, especially when it gets to like the exam and the FSA at the end of the year. They will save you time. On every test from this point on, you'll have triangles, and if you know your triples, they will save you time because instead of having to do Pythagorean theorem to find a missing piece, you can use the triples to find them a lot of times.
Is there a way to recognize a triple without like knowing it by memory?
Not really. Just knowing it by memory. That's the only way. All right, so we have that missing piece. Again, the triple wasn't even part of this question, right? The triple, in this case, helped us find this one side, so now we can answer these so that there's no work to do. If I didn't know the triple, then you would have had to do Pythagorean theorem. You would have taken probably about a minute or two to do that, and then 2 minutes later, you could finally start answering the question. If you know your triple, you know it's 24, and you can answer your question right away. Because now it's just a matter of saying sine of m, that's opposite over hypotenuse. So 7 over 25. Cosine of m, that's going to be adjacent over hypotenuse. So 24 over 25. Tangent of m, that's opposite over adjacent. So 7 over 24. Sine of O, I'm going to move this over here because that's getting a little crowded. Sine of O, going from this side. Now, do I really have to figure each one out again by looking at the triangle? No, because sine of O should be the same as cosine of m. So 24 over 25. Cosine of O should be the same as sine of m, which is 7 over 25. The tangent of O should be the reciprocal of tangent of m, so 24 over 7. Again, if you want to look back at the triangle, you can look back at the triangle and figure it out as well. It works. But again, there are multiple ways to do that. All right? expression is equivalent to cosine of 25? Again, this is like the problems that we did in bell work earlier today. Which expression is equivalent? So again, if we're looking for a ratio that is equivalent to sine or cosine, remember, it's this property right here. Sine of an angle is equal to the cosine of its complement. So the values have to add up to 90. Here, cosine of 25. All right, so we're going to be doing a sine value then. And again, if you subtract 25 from 90, then it's 65. So we're doing sine of 65. And that's it. There's no work to do there. All it is subtract that number from 90, and then it's the opposite of whatever it was. If it's sine, you do cosine. If it's cosine, you do sine. So again, always the opposite one. Any questions up through 7? Now, from 8 on this worksheet, that's where they started to get a little more challenging. Because now, from 8 on, you had to set up your ratios and solve for all the different missing parts of these triangles. For this next one, they even ask you to do perimeter and area. So not only do you have to find every single side, but you also have to find the area and the perimeter of each one of the triangles. So you have to keep in mind, for perimeter, you're just adding up all your sides. For area of a triangle, area is 1/2 base times height. So we have to make sure we identify the correct base and height as well. Now, base and height are always the sides that are going to be perpendicular. So, on the first one, 8a, we have 2 sides to solve for. Now, I'm going to go ahead and label these 2 pieces as x and y for the time being. All right? Because it's going to help us identify when we're writing our equations what we're actually solving for. All right, there's not a lot of room on here, so I'm going to use some sticky notes. So on this first one, if I want to solve for x, now this is given to me as 78, right? That's the angle I'm going to use to identify which ratios I'm going to do. So if this is 78, this side is what compared to 78? So it's opposite. And then the y is my hypotenuse. The 29 is the adjacent. So now, one of the questions that I had a lot as I was helping people was, I have all 3 parts. Which ratio do I use? Well, on here, 29 is given to you as a value. So that 29, your adjacent piece, has to be used to find both of the other pieces. So you have to use adjacent. Now, there are 2 ratios that use adjacent. There is cosine, which uses adjacent and hypotenuse. So cosine is going to be used to solve for y. Whereas tangent is opposite and adjacent. Opposite and adjacent. So tangent will be used to solve for x. We won't use sine here at all because we don't have either the opposite or the hypotenuse given to us as a numerical value. So we can't use sine to solve. We're going to have to use, again, cosine in order to get our hypotenuse and tangent for the opposite side. So let's set these up. We're going to do cosine first. So we're going to find our hypotenuse first. Cosine of 78 is going to equal the adjacent, 29, over the hypotenuse, which I labeled as y. Again, I just gave them different letters just so it's easier to follow the work. It doesn't matter what you call it. If you wanted to, you could have called this O and that H. Right? Again, it doesn't matter. So now, on here, I need to get the y by itself. So first step, multiply by y. So we'd have y times cosine of 78 equals 29. Again, if you set up like a ratio like Miss Oswalt was having you guys do, you'd still get the same value, right, after you cross multiply. And then we have to divide off cosine of 78. So 29 divided by cosine of 78. which again, we're just plugging that into our calculator. If you want to do cosine of 78 first, just make sure you use a few decimal places so that you get an accurate answer. So I like typing the whole thing into my calculator as is, cosine 78, and that gives us 139.482. 139.482.
And you only given it like the exact answer when it's angle?
Again, most of the time, if it's an angle, the directions will be round to a whole number. Sometimes they might say round to a tenth. They usually don't have you go to more than that if it's an angle. If it's a side, a lot of times they'll have you go out to at like 3 decimal places. All right. So if I don't give you any directions, rounding directions, I recommend rounding to 3 decimal places. All right. So that was for y. Now, to get the other piece, the opposite side of 78, we're going to do tangent. So tangent of 78 degrees equals opposite over adjacent. So x over 29. So now on this one, again, bring the 29 over to the other side. You're doing 29 times tangent of 78. Again, just typing that in the calculator. 29 times tangent of 78 goes 136.434. 136.434. So those are my two sides. Now, yeah. Okay, before I go on to anything else, I want to explain one other thing here. Because could I have actually used sine to solve for my x value? Yes. Because now I do have the hypotenuse. We found it, right? So if you found the hypotenuse, now we have the opposite and the hypotenuse. So you could use sine. However, when you do sine, your answer might not be as exact because depending on what you rounded to for your hypotenuse, again, if you rounded this off to a whole number, your value might look a little different for this one. This is more exact because I went back to the original value that had a whole number with it, so I didn't have to do any extra rounding before I got to the final answer. Now, if you rounded to many decimal places, like I did here, your answer might be exactly the same. Again, it depends how many decimal places you went out. All right? Okay, now, we actually aren't done with this problem. No, because this one asks for perimeter and area. So we have the two parts. You have to find perimeter and area. So for perimeter, you're adding them all up. 29 plus 139.482 plus 136.434. So add them all up.
Wait, so you added all the ones on the outside?
Yep, again, that's how you get perimeter, right?
Yeah.
So that's 304.916. That's our perimeter. That's one of our two answers. The other answer is for area. Again, our area formula, 1/2 base times height. The base on this would be our opposite side, which I labeled as x. So 136.434. And the height is the 29. So I'm going to do 1/2 times 136.434 times 29, which is 1,978.293. Now I rounded at one point there when I plugged into this. So my answer might not be as exact as somebody else's answer for this one. So again, keep that in mind. These are all rounded answers. but that would be the other value for your area. Now, that's for number 8. Should probably keep track of what all these sticky notes are for, because this was for number 4. B and C. This was for number 3. All right. All right. So again, that's a lot of work for one problem. But again, that's what's required on this one. Now, there is more than one way to do a lot of these problems. All right? So, I just told you a second ago, could I have used sine to find this opposite side? Yes. There's one more option, too. It's in tape, right? Yeah. Now, the other option, Pythagorean theorem. Once you find one missing side, you have two sides. So you could also use Pythagorean theorem to find the third side. All right. So on this next problem, I'm going to do that. All right. So again, there's lots of different ways that we can go about solving this. I'm just trying to show you different methods that you can use for these different problems. So let me write my answers for number 8 on this paper, just so that they're written in. So for this next one, again, I'm going to actually call these B and H this time, because I'm going to have to use one as the base and one as the height, and we have to solve for both of them. All right? But again, you can use whatever letters you want for each of these. I'm just trying to use different letters so that as I'm going through and solving, it's easy to identify. Now, this one is 36. So, based off of this 36, this would be my what side?
That's the opposite.
This would be opposite. This would be adjacent. And the 11 that's given to us is the hypotenuse. Now, does it matter which one of these I solve for first, B or H? No, you can solve for either one. So let's solve for H, because I want to do sine. All right. So we're going to do sine. What is this? This is number 8B, isn't it? All right. So I'm going to do sine of 36 equals H over 11. So now, in order to solve this, I need to multiply 11 to the other side. So 11 times sine of 36 equals H. So type that into your calculator. So we have 11 times sine of 36, which is 6.466. 6.466. Now again, but then the next value after that is a 6, right? So you got to round it up. Again, whatever you round to, you got to make sure you look at the next value so that you're rounding that value off correctly. Now, that's that one side. That's H. We also need B. So now, to find this side, the adjacent side, instead of doing this again, I could go the route of cosine. Or, if you want to, we could now use Pythagorean theorem, because we have two sides of a right triangle. I personally think the cosine way is easier. But again, I'm going to show my work for this one, because I just want to show the other options. Because again, it depends on the problem. Sometimes Pythagorean theorem is easier. Sometimes using one of the trig ratios is easier. For this one personally, I think the trig ratio is easier. But I'm going to show Pythagorean theorem since I haven't done one like that yet. So I got the 11 squared equals, well, I just found h was this, so 6.466 squared plus b squared. So now I like keeping values as exact as possible. So when I do this one, I'm going to go ahead and type this into my calculator like this. I'm going to move this over first before I actually square anything, so that I can type it in with those two squared values. So I'm going to do 11 squared minus that 6.44 squared, which I have as my last answer. So answer squared. So my value is 79.9155. So again, I'm going to round up. So 79.196 is going to be my B value. Oh, I didn't mean to write that there. It doesn't really matter, but that's my B value.
You just did it all in one step in your show?
So that's my B value. Say again? So, like this, I typed that whole line into my calculator.
Oh, so you just didn't show the work of doing 11 times 11.
Yeah, I didn't show what they were because I can do that in the calculator and subtract it and figure it out as an exact value.
What is that
So I
one
just
for? 79.1659.
So that's for B. That's for the other side. That's for this side. So we have our two sides. Now that we have our two sides, we can find our area and a perimeter. Right? Let's do perimeter first. So perimeter, we have 11 plus 6.466 plus 79.169.
Oh, how'd you? I don't get how you got 79.169.
All right. Did you use Pythagorean theorem like I did, or did you go cosine route?
I did cosine.
All right. So if you did cosine, yeah, let me show cosine, because it should have ended up just being 11, because we had the hypotenuse, right?
Yeah.
So it should have been 11 times cosine of 36.
Oh, that's right. Never mind. I did 42. Let's get the next one. Thank you.
Wait.
And I got that number, yeah. I got that number. So I'm very confused because I got that.
Wait. What did I do?
Because I got 8.899 to round up.
Oh, I forgot something. Look at my B. What am I missing there?
I don't know, that's what I'm trying to hit
That was squared still.
Oh,
I forgot to take the square root.
I was wondering why it was so big compared to the other numbers.
Yeah, so sorry. Take the square root of that, and it's going to be 8.899. Sorry, so correction. Yeah, that number is way bigger than the others. That didn't make sense.
So you got the answer wrong?
I did. I forgot to take the square root. In Pythagorean theorem, you have to
See,
square
that's
root
why
it.
you can't skip steps, Mr. Steezy.
Well, I didn't skip it. I didn't write the squared on it when I did my work.
Okay.
So that should have been 8.899. So now adding them all up, which makes a lot more sense. 11 plus 6.466 plus 8.899. Perimeter is 26.365. That's one answer. Area, 1/2 base, which is the 8.899, times height, times 6.466. So 0.5 times 8.899 times 6.466 is 28.744. That's what I got. Because it's 437, so I rounded up.
Is that the area?
That's the area.
How much time are we gonna get?
That's not what I got.
For the test,
For the area, don't you?
a class period.
That's it?
Yeah. Now, am I going to ask you 5 questions like this one? No. You might have one question where you have to find area. I don't even know if I threw area on the test because truthfully, area doesn't really come up until the next chapter. Like we don't have area form this in this. Yeah, it's all one day. 3 parts, 1 day.
The first part's the easiest part, right? So that's just
Yep.
looking at, you know, your formula.
No, less than 30. I don't remember off the top of my head, but all right. So that was for that one. All right, we still got a couple more here. This one.
Oh, wait, never mind. Mercer broke it.
Yeah, I'll leave it there for a minute. All right.
Thank you.
Yep, you're welcome. All right, for C, we have one of the sides. Now, on this one, I'm going to do this one a little bit different as well. We have the 42. We could use that 42, all right? Now, I haven't really done this in class at all, but if you wanted to, I don't have to use the 42. You could choose to use, huh? Yeah, so we know this other angle, right? What is this other angle?
Oh, well, you gotta do 1.
40.
Wait, don't let me type it in the calculator.
Don't type that in the calculator. Because again, yes, I know you said they all add up to 180, but also the 2 acute angles add up to 90. So subtract that from 90.
That's smart.
So that's 48. So I could choose to use 48 instead. Say, again, it doesn't matter which one of those 2 angles you end up using, right? So you could do your work based off the 42, or you could do your work based off the 48. So, and you should get the same answers. So, all right. So, again, you can do either one. Since you guys want 42, I'll do the 42. But let's say we do our side over here. All right, I'm going to do this side first this time. So, if I use the 42, this is opposite, and this is adjacent. So I'd be using tangent, right? So I'd have tangent of 42 equals this unknown side. Let's call it, I'm just going to call it x and y again. So that's x, that's y. So we'll say tangent of, let's see, x over 30. And then to get rid of the 30, we're going to multiply. So 30 times tangent of 42 equals x. Again, multiply it out. So 30 times tangent of 42. Yep. Going to give us 27.012.
How do you get that? I got 1260. Oh, maybe my calculator is in the wrong mode again. Yes, in grad. Never mind. It always does that. It keeps going out of the wrong mode. It's supposed to be day.
Yeah, it's supposed to be degrees.
Okay, my thing keeps changing by itself.
Shouldn't change by itself. Maybe you bump it. I don't know. It might be your nails.
Oh. Wow, the shade.
Well, I mean, seriously, you have long nails. It might be.
That's true. I gotta be extra careful, man. 30 times 10.
All right.
42.
So then that should be that side. For y, again, if you want to do it as a trig problem, this is our hypotenuse. So I could do adjacent hypotenuse. That'd be cosine. So cosine of 42 equals 30 over y. Say again?
This is the one where you see the opposite and adjacent the same, so you don't flip it.
Again, if I'm still going off of 42, then I'm not going to change it. Now, if I wanted to use the 48 instead, then you can change it. So again, some of these there's going to be more. Actually, every single problem we do, there's more than one way you can find the correct answer. So again, multiply the y over to the other side. But then we're also going to have to divide off cosine 42. So y equals 30 over cosine 42. So we have 30 divided by cosine of 42. 40.369. So now, once you have those values, again, you got to do your perimeter and you got to do your area. Perimeter, add them all up. So we got the 30 plus 27.012 plus 40.369. So for perimeter, see, 30 plus 27.012 plus 40.369. That's 97.381. For the area, 1/2 times the base, which was the 27.012, times the height, which was 30. So, times 27.012. That'd be 405.18 for the area.
So it's 2.27. 2.27 times what is that?
Which one are you looking at? This area? That's 1/2 times 27.012 times 30. So again, 1/2 times 27.012 times 30.
Yeah, okay. Thank you.
Yeah. So that's all of the front side of that page. So
Yeah, that's like just go on with the
Yeah.
area. It's like you saw from.
again, you're not going to have a whole lot of problems like that.
It's not that bad though. I understand the choice.
Yeah. Now the back part of this, I don't think it takes nearly as long. 12 is a little bit long for a problem because again you're finding all the missing pieces. But other than 12, the rest of these are very short. On 9, you're finding both x and y. Again, you already know what one of the sides is, so and it's the hypotenuse. So we're going to use both sine and cosine to find x and y. So on here, we know that this is 42. We have the hypotenuse based off of the 42. Y would be your opposite. X would be your adjacent. So if we did, let's say we're solving for y first, it'd be opposite and hypotenuse that we're using, so we can use sine. So sine of 42 equals opposite y over 18
And then you times both sides by each.
times by 18.
And then it'll
So sine of 42, which is 18 times sine of 42, 12.044.
So y equals that.
Yep, that's y. And it said round to the nearest tenth, so actually we want to round this off to
Just the.
here, which is just 0, so it's just actually 12. So 12 or 12.0. For the other one, x, again, adjacent this time, so adjacent and hypotenuse, you could use cosine. So cosine of 42 equals x over 18. So it's just 18 times cosine of 42. So that's 13.377. Again, wanted to round off to a tenth, so 13.4 we'd have to round up. So that's it. See ya. All right. Now, on number 10, they only ask you for one piece. They just want to know what that rope is that they labeled as X. So you have your angle. This is our hypotenuse. This is our adjacent side. All we have to use is cosine, because adjacent and hypotenuse is cosine. So cosine of 50 degrees equals 3.5 over X. Again, you'd have to multiply by X first. So you get X over to the other side with cosine. Then you'd have to divide off cosine to get X by itself.
And that's the opposite, right?
So 3.
I thought you could do the negative thing.
Nope. Again, if you're solving for an angle is when you're going to do the inverse.
Oh.
Right. Nope, you're fine. So then 3.5 divided by cosine of 50.
I see. You wouldn't need to do that. You do that being less. So there's a little bit.
5.445. Let's say what's around to? Nope. So that's going to be it. And this is going to be in feet. This one did give us units, so you should include your units.
Oh, you're taking points off, right, for not having.
There's a good chance I'll take a point off if you don't have the units, and it gave you units. Yeah.
No, like, talk about the degree symbol.
The degree symbol, yeah, you need a degree symbol. Because again, you now know that there are two ways to measure angles. So if it's a question where you're trying to find an angle measure, it should definitely have degrees on it. Because if the degree symbol is not there, then in math, it's usually assumed that it's radians. So the degree symbol becomes very important when we're finding angle measures, especially in trig. So on number 11, use a scientific calculator, graphic calculator to evaluate each of the following to the nearest tenth. Again, they're just taking inverse sine. This is just back to plugging the calculator there. So we got inverse sine of 1/2, which is 30. Inverse cosine of 1/4. 75 point. They wanted us to round to nearest tenth. And then tangent, inverse tangent of 0.6. That's 30.96, which will round up. So this is going to be 31. Again, all these values are what that we just found. They're inverses, so what do we actually find? If you do an inverse, we're solving for it.
They're the ratios, right?
No.
No. No. That's what the other thing when you do that's sine in the code.
Yeah.
So the opposite of sine?
So again, if we do the inverse, it's because we're solving for an angle. So on these, this is where you need to make sure you put a degree symbol because these are angles in degrees.
You just said that 5 seconds ago, and I wrote it down.
So the other ones you don't put the other.
Yeah. Again, when you do the inverse, you're finding a degree. So now, number 12, it says solve each right triangle if possible. Round your measures to the nearest tenth. So 12 is one that's going to take a little bit longer because you're finding all the missing pieces. Good news is you don't have to find you don't have to find the area in the perimeter. Now, they do want all the parts, so they do want all the angles and all the sides. So on A, we have 62 already. We can find the other angle. This angle over here is going to be what?
That's going to be...
So subtract 62 from 90, you're left with
90 minus
28.
28. So now, for the other sides, again, we can use either the 62 or the 28 in order to solve for the other two missing pieces. I would say pick one.
28.
You want to use the 28?
Yeah.
Why do you want to use 28?
Smaller.
62.
But that doesn't really mean anything in terms of these problems. All right. So I normally use the angle that's given to us originally because there's no real order that we have to go in. So like some people might do this problem. We did the angle first. Do we have to do the angle first? No, because we had this angle given to us, so we could have solved for these two sides first. So the 8 that was given to us is the adjacent leg compared to 62. The other leg that's here would then be the opposite. And then this would be our hypotenuse. Now, just to give us some values so that it's easier to tell what we're solving for here, I'll call this one x and this one y. So if we solve for x, x is our opposite. We're using opposite and adjacent, which is tangent.
Is
Tangent. Tangent. There's no r.
I always do that. I don't know why.
Opposite is x, adjacent is 8. So we're just multiplying by 8. 8 times tangent of 62. 8 times tangent of 62. And again, this one's out is round to the nearest tenth. So this one is 15.04. So it'd just be 15.0 or just 15. Either one's fine. Now, that's for this side.
Oh,
For the other side, again, you have options. We could decide to do our our Pythagorean theorem again. All right, because we have two sides, and really, this one would be easier to do as a Pythagorean theorem because it is Pythagorean triple. So if we just found that that one was 15, the other one would have to be 17. So we don't even have to do the rest of that work. Now, for this, again, most people I don't think would have done that, so we would have probably used our trig. We had adjacent, we had hypotenuse, you'd be doing cosine. So I'm going to go ahead and show the work for cosine real quick. So let's say we did cosine of 62, and we had the adjacent, which was 8 over our unknown side of y. We were multiplied by y, said y equals cosine of 62 equals 8, divided by cosine of 62, so y equals 8 over cosine of 62, and we should get something very close to 17. So 8 divided by cosine of 62, 17.04, which does round off to just 17. On B, you have two sides. To find that third side, I just use Pythagorean theorem. You have two sides of a right triangle. We might as well find the third side using Pythagorean theorem. So let me draw a line here. That was all for that first one. For this side, if I plug into Pythagorean theorem, I'd have 8.5 squared equal to 6.5 squared plus this unknown side squared. I'm going to call it x. So now, 8.5 squared.
That's 72.25.
6.5 squared. 42.25.
Yeah.
Subtract the difference there. 72.25 minus 42.25 is 30. That's still squared. We got to take a square root.
Yeah, so that's going to be
So
5.477, but there's a plus around. Round to the nearest 10. So 5.6. I mean 5.5.
Oops, I hit the wrong button there.
It's 4 go to 5. I mean 6. I think it's 5.5.
So this would be 5.5, yeah,
Sorry.
when rounded. Now, for the angles, I wouldn't use the 5.5 since we just rounded that. I'd use these two. We're going to have to do the trig ratios to solve for the angles. So, let's do E first. If we do E, now, you're going to have to change what these things are labeled as for this one because we're solving for one angle and we're solving for a different angle. Or, once you solve for one angle, then you can subtract from 90 and you have the other angle. So, again, two different ways of doing it. It's probably just easier to find one and then subtract from 90 to get the other. So, let's say we solve for E first. If we base this off of E, right here, I'll use a different color. If we solve for E, this would be our adjacent, and this would be our hypotenuse. Now, I'm not going to do the opposite because we rounded. So I don't want to use the opposite. So I'm just going to use adjacent and hypotenuse. So this would be cosine. So cosine of E equals 6.5 over 8.5. When we solve for an angle measure, that's where we have to do the.
Oh, the degree symbol. Right?
So we're going to get a degree because we're doing an inverse operation. So what you're going to do the inverse cosine on this one. 6.5 over 8.5. So again, plug that into your calculator. So that's 40 point. What do they want us to round to? Yeah, it's 10th. So 40.1. So E is 40.1 degrees. Now, since we know that that is 40.1, we just need to do 90 minus that.
90 minus 40.1, that's
49.9, if again you round off to the nearest 10th. Now, for C. Why not?
That's 72 right there.
Yeah. We can't solve this one because there is no side length. We only have angles. And again, there's lots of similar triangles that would share the same angle measures, but would be completely different sizes. So we need at least one side in order to be able to solve for all the rest of the sides. So can't solve because there's no side. On 13, a skateboard ramp has a slope of 4 over 9. What is the measure of the angle of the ramp forms with the ground? So it doesn't matter how big this ramp is, because no matter what, it told us what the slope was, and the slope is the change in y, the vertical change, over the change in x. So now, it doesn't necessarily mean that it is a 4 by 9 ramp, but 4 by 9 is going to be, like, if we knew the actual lengths, this ratio would have to hold true no matter what, right? So this could be 4x over 9x. Or sorry, 4x and 9x. Doesn't matter, all right? We can use 4 and 9 to help figure this out. So it wants the angle the ramp forms with the ground, so this angle right here. So using this angle, this would be opposite, this would be adjacent. Opposite and adjacent is,
I have a question. How can it say to assume that it's 90 degrees?
yeah, because 4 and 9, that's the vertical change and the horizontal change. Vertical and horizontal are always perpendicular, right? So it has to be a 90.
Okay.
So this would be tangent. Now, so we're doing tangent of our unknown angle equals 4 over 9. So, in order to get that angle, so we're doing the inverse, whoops, so inverse tangent of 4 over 9, which is inverse tangent of 4 over 9, 20, let's just round this off to a whole number, 24 degrees. Now, this, I'm not going to get really far into trig, but something that, I don't even want to show that, never mind. I just confuse you guys right now. Let's go to 14, last one. Which expression is equivalent to the inverse sign of 0.5?
He's gonna get a target shortcut.
So,
We're not ready for the shortcut.
so the inverse sign of 0.5.
No. Wait, what?
Which one of these is equivalent to the inverse sign of 0.5? What do you
Now
think?
the next question.
90 degrees
Oh yeah.
minus, yeah. And
Why do you say that?
because how I solved it was I just solved sine whatever and I got 30. And then I went down the, it's probably not a good way to do it.
That's fine.
Why can't you just go through every?
So-
for that and just go through every single one.
So, the idea here, it goes back to this concept that I had in the lower corner of the board. Sine of an angle and cosine of its complement are equal.
So that so
Right.
you can just subtract.
Because on here, this is going to give us an angle measure, right? Which you told me is 30, right? So its complement is 60. So which one of these gives us 60?
A B,
Oh, wait. Wait, was it?
Okay, so now
I said that wrong. I said that wrong. Hold on.
our answers are
Hold on. I said that wrong. We need it to still be 30.
C is 30.
C is 30. I used the right thing to explain it, but let me try that again. So we want it to be 30, and we know that the sine of an angle is equal to the complement of its cosine. So here, this one here, this is essentially going to be the cosine, right? We're subtracting whatever angle this is from 90. Therefore, we're talking about its complement. So again, you could, without really doing the math, figure out that it's C based on that idea. It's probably easiest just to do what you did and solve each one. This would give you 30. If you were to plug in for each of these other ones, this one is also
But
30.
it's still kind of obvious though, because you said the whole complement. It could only be sin and cos, right?
Yep.
It goes on to the work to 90.
Yep.
Did we ever ask what a cosine is about?
I don't think that they make anything like this complicated, because this idea gets into other stuff from trig too, which is higher up. Stop this.
So what do we take?